Hi, my name is Tina Liu, and I'm here to do the homework 10 problem 2. And it's similar to the problem 1, so we just need to write out the definitions and properties. And for the first one, we have the wire sense stationary process. And from the lecture notes, we can say that it's as WSS if the its mean, which is the x bar value of the xt used to mean is equals to the constant, and uh, its correlation is the depends on the t1 minus t2 only, which is the uh, which is the autocorrelation depends on t1 minus t2 only. Okay, this is the very basic WSS definition. Uh, so for this one, I think as a basic definition for us to do in the following, and for the next one, we'll have the independent increment process. And for this one, we just have the xty minus xt2. It's a one time period, and the next one is the xt3 minus xt4 on non-overlapping intervals are independent. Uh, so for this one, we can apply this process onto the Poisson part, onto the random walk and the winner process. Uh, so for the next one, we will have the Markov process, which is that the past has no influence on the future when the present is known, right? So it applied a lot on the other process like the Poisson impulses. I think the random walk is also one, and many other will be. And I think the key is that it's the no influence part for the past to the future. And so for the next one, we will have the normal process. The normal process is quite uh, obvious that we only need to remember one form is the when the fx x1 x2 equal to the xn with the known t1 t2 to the tn, we'll have this form with the 1 with over 1 over square root of the 2 pi with the n order and multiplied by the square root of the determinant c, and with the exponential of the negative 1 over 2 x mu t multiplied by c inverse and multiplied by another x minus mu right? So it's the say that we have the random variables. We have the random variables. Sorry, variables of the xt1 to xtn, and they are jointly normal for any um, any t1, t2 to tn, and which this is represents the oral definition for the normal process or the equation above. And for the next one, we will do the strict sense stationary process. And for this one, we can also remember one form, which is the normal process x1, x2, blah, 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 to xn. Excuse me. Okay, and t1, t2, go, go, t2 to tn, well, equals to the fx. The x1 to xn is still the same, but for the next part, it will be t1 plus epsilon with the t2 plus epsilon, and so on to the tn plus epsilon. So this equation is very hard to be satisfied, and the SSS process is very hard to satisfy. And so also one part is that if xt is the normal and the w is and s also the y sense stationary, it will be the strict sense stationary process. And it's the extra part. And for the next one, we will have the y noise. For the y noise, we will say that uh, it's usually in the winner process, and we will have that for the determinant t, which will equals to the derivative. It's not determinant. Sorry, it's derivative t, which represents the derivative of wt via the t, and we will have that if the x bar value of the derivative t is equals to 0, and it's under and its autocorrelation function will be the alpha multiplied by impulse function of the t1 minus t2, and we will have it as uh, the white noise part function, and as I said, it's usually in the winner process, and so so if, if this one is satisfied, this part is satisfied, this alpha is usually represented as to q t1. Uh, it will be say that the dt is the white noise function, and for the next one is the mean algorithmic process, which is also the equation. It's limit of the t to the infinity with the 1 over 2 t, so t negative t, and the xt dt will equals to the uh, x bar value of the xt in mean square sense. Uh, like the condition of the mean square sense is very important for this problem. So we only discuss it under this condition, that this equation satisfied is the mean algorithmic process. And for the last one is the martingale, which is the of the x bar value of the xt axis equals to x1 equals to x1, where s is less or equal to t. And for this part, we can see it's on the uh, it's on the clue of the homework 9 part. And in oral, it's that martingale is a sequence of the random variables for which at a particular time the conditional expectation for the next value in the sequence is equal to the sorry is equals to the present value regardless of all prior values. And I think that's it for the problem 2.